Welcome to the second video on the classification of stellar spectra. In this video we'll show you how to access the telescope so that you can collect spectral data and then do a quick review of how to call that up so that you can classify the spectral type of the star. We'll assume that you've logged in and have this window showing. We'll need to access the telescope, optical telescope. Pick the largest telescope available, which should be the 4-meter out of Kitt Peak National Observatory in Arizona. The default is for the observatory to be closed, so this is the inside of the observatory. Let's open it up. You'll notice some sound effects. That little clinking sound at the end is we found a symbol that you may run into some built-in problems. They've tried to make this program as realistic as possible. Usually means double clicking. You might click on something and it won't go at first, so you have to click a couple times. We'll see if that happens in our efforts. The first thing we'll need to do is to turn on the telescope control panel. There's the sky from inside the observatory. The next thing that we're going to want to do is turn on the tracking, and that way we can go from the finder. This is just from the inside the observatory, and now we would be looking through the telescope, and you'll see these two little slits. This is where the light would be collected for the spectrometer, which should be the defaulted instrument of choice. Let's put it back to finder. Your particular star will be found on the assignment on Canvas. We'll pick a different star to show you generally how it works. We're going to actually set the coordinates. So you can see that I've set the coordinates to 8 hours, no minutes, and 48.8 seconds of right ascension, and 19 degrees, 48 minutes, and 56 seconds of declination. We'll hit OK. The telescope will ask us if those are the actual coordinates. Double check, and then yes. Again, some more sound effects, and we're there. We'll go to the telescope view, and a star should appear in the between the slits. If there's no star, you most likely enter the coordinates incorrectly, so double check the coordinates to the coordinates that you're supposed to go to. We'll access the spectrometer. The default should be all set, so we don't need to change anything up at top. We'll hit go, and then we'll hit stop. This number, signal to noise ratio, just needs to be over 100. You can see mine is 800. That just gives us a really good data. Depending on the size of the telescope and the brightness of your star, this may take more than the time it just took this star. At this point, we'll save that spectrum file, and we'll save the spectrum. The important thing to notice here is, first, it already has a name. Do not change that name. This is star 02046. It's a catalog name for CLIA, so it matches up with a real star, but we don't want to actually let you know what that star is. And then up here you'll see the path name, and it should go to your folder. Remember, we're working as Joe Schmo. This will be important if you do this and then have to leave the program. When you come back, this is where your data will be, and we'll hit save. There it is. Now, there are a couple stars that we'll be doing together on the CLIA program through Canvas. You need not print those out, but for the very last part of the lab, that would be set C and the uploads, you actually have to print your spectrum, and you'll do that right here at the same place where we did the save. File data, print spectrum. And when you do that, it'll print out a hard copy with your name on the top, the date that you printed it, and this information down here. So just be aware, you cannot print this from any other place in the program. Now, if you close this out, I've saved it, I'd have to go back to the star and recollect the data if I was going to print it. All right, a real quick review of how to classify that spectrum. We would go to Tools, Spectral Classification. Here's our spectral classification window. You should have already run through some sample classifications. We'll go to unknown spectrum. We'll move this over here so you can see it. Unknown spectrum, save spectra, and there's our spectra that we just took. Now, after a while you might build up a pile of stars. You'll need to be careful to make sure you pick the right one. Let's pick the Atlas of Standard Spectra. We'll always start with the main sequence. Let's show the difference. We should have done this before as well. Show the difference. And let's run through the spectra to see which one it might be. It looks something between a K0 and a K5. But as in the previous part of this lab, we know that we should probably check whether it's a different type of star. Is it a K01? That'd be a K1 supergiant, or is it a K03? Oh, look at that. That's a very good match for a K0 giant star. So it looks to me that this would be a K03. That's a red giant star, and that's then what you would use to find the absolute magnitude. And if we saw its apparent magnitude back on the previous spectrum, previous spectrum readout, you can then find the star's distance. And that's pretty much how you would find the distance to the stars for the remainder of this lab.